I'm charge techs, and I have to stop burning my nonstick pans. It always starts the same. I get hungry, so I go to the kitchen, get out my ingredients, and put my pan on the stove to warm up. As I wait for the pan to warm up, I get bored, so I go to do something else for a few minutes while I wait for it to heat up. 10 minutes later, I realize I left the pan on, run into the room, and find my pan scorched. Oh, shit! Okay, that was a bit of an exaggeration, but you really can burn your pans if you heat them too much. Nonstick pans can release toxic fumes and even permanently lose their nonstick properties if you heat them above about 500 degrees Fahrenheit. Today, I'm going to change that. Not by changing my habits, but by over-engineering a sensor that'll notify me when my pans are getting too hot. This is an MLX 90640, a thermal imaging sensor that I'm going to be using to protect my pans. It can only take 8 pictures a second and maxes out at a wimpy 32 by 24 resolution. Compared to a modern smartphone, that's 7.5 times as slow and over 10,000 times lower resolution. But we're not shooting a Marvel movie here. We're taking pictures of some pans. So this should be fine for its purpose. My plan is to use the MLX 90640 to constantly monitor my stove. If it ever gets above about 450 degrees Fahrenheit, I can attach a speaker and I can use that to make a noise that'll notify me. That way, I can run into the kitchen if it gets too hot, take the pan off, or put some food in it to cool it down. So I bought a display off Amazon, and after a bunch of trial and error, I'm able to use an Arduino to get the temperature data from the sensor to the display here. What you should be seeing right now is the display updating in real time with the data from the images it's taking for me. I'm doing a T-pose right now, and next I'm going to do a dab, and you should be able to see that I'm much warmer than my surroundings. Now, it appears that for some reason the image is mirrored on the display. It's going the wrong direction, but I can easily fix that in software later on. Okay, now that I can reliably read temperatures, all I need to do is a way to play sound when the temperatures get too high. That's where these bad boys come in. I bought a bunch of cheap speakers from a local electronics shop. Now, all I need to do is wire one of these in, add some resistors to be sure I don't blow it up by mistake by giving it too high of a voltage, and I should be able to play a noise anytime the temperature gets too high. All I need to do now is solder it up, so let's get to it. Okay, so what are our next steps? First, I have to get the speaker working. Then I just have to 3D print cases for everything, assemble it all together, and install it in the kitchen. I decided to do a quick test of the speaker before I put everything into a case and assemble it all, and it's a good thing I did. When I plug it in here and play a sound, you can hear that it's not very loud. It's probably not going to reach into the office here from the kitchen, and it's definitely not going to be able to be heard from the bedroom or some of the farther parts of the house. Luckily, I know what the problem is. The speaker circuit I've made draws a total of about 1.2 watts when it's playing, which is way more than the Arduino's pins can handle. So I need to get a transistor and then turn that transistor on or off based on the Arduino's outputs. For that, I'm going to have to go to the electronics store. So I got my transistors, and these should be able to pass enough current so that we can make it a little bit louder. I should just need to attach them and we should be good to go. Okay, it's kind of a mess here, but if I plug this in, it should play at the same volume it was playing last time. Just kind of a low volume. You're able to hear it, but not super loud. Okay, so it's working just like last time. Now, it's time to switch the output from the board itself to the MOSFET that the board is powering, and we should hear it be much louder. All right, let's see. That wasn't really louder, I'm gonna be honest. Okay, after taking a look at the datasheet, which I should have done to begin with, I realized that the pins to the transistor were not ordered in the way that I thought they were. So if I switch them around here, we should get a much louder sound. Okay, let's try again. All right, the case is printed. I just need to do a little bit more soldering to reconnect some things that weren't connected correctly. Then I should be good to go. Well, I was trying to avoid the issue of not having enough wire to connect everything together, but it looks like I've run into the issue of having too much. So I'm gonna have to trim these wires down and resolder everything so it'll fit in the case. I'm so close. Okay, second solder montage. All right, everything is complete. Now all that's left to do is just mount it to the wall. So I'm using these Velcro command strips. And I should just need to peel this and then stick it up here where it's gonna go. Yeah, it looks to be working. I'm gonna connect it really quick to some power. All right. It appears to be working. Now, all that's left to do is to test and be sure that it's able to trigger properly. So, I'm gonna take a pan and put it here. We'll go ahead and crank it. Now I have an infrared thermometer here, and I'm gonna use it to see when we go above the temperature that it's looking for. Okay, it's about 420 right now. So 430 now. Any second it should start to go off. 456. It may not be exactly calibrated the same as this, so I'll let it go a little bit hotter. Okay, I'm seeing smoking. I'm gonna have to take it off. It's a little bit loud. Yeah, okay, it's definitely going off. Okay, all right, that's it. It appears to be working. It appears to be mounted to the wall. I think that's everything for this project. If you liked this video, please like it and subscribe. Write in the comments if you have other video ideas for weird things I can do around the house to make my life better. Thanks for watching, and I'll see you next time.